everyone, it's Alyssa and welcome to You Can Learn Math. Today is about finding the vertex of a parabola. How to find the vertex of a parabola. Now I'm assuming that you already know about what a parabola is. You know, its basic shape, that we often see it written. I'm going to write over my parabola, woohoo! That we often see it written in this form. It's a quadratic equation. I'm assuming this is, you're like, oh yes, I'm aware of this. I know what a parabola is. I have seen this form before. Okay. And I'm not talking about finding the vertex when it is in vertex form. That is actually another video I'm going to have published later this week. Link will be in the description below. If you're trying to find out more about vertex form of a parabola, either what it is or how to convert a standard quadratic into vertex form, go to that other video. Link in the description below. This one is, you have a parabola that is some variation of this, where your A, your B, and your C are just numbers. These coefficients are numbers. Now, granted, these B and C may be 0. It may just be like an ax squared. Or it may be just ax squared plus bx, or ax squared plus c. Those are all fine. Those are all versions of this. But it's some variation of this, and we need to find out where its vertex is. So in order to find the vertex of a parabola, first we have to find the axis of symmetry. I don't know, it almost sounds like a band name. The axis of symmetry. That means, when I draw a very poor parabola like this, what is the line that if I split it, oh that's so bad, if I split it right down the middle, it would be a mirror image on both sides. Think of like, you know, if you have a triangle. Man, I cannot draw for nothing today. Okay. You know, what is the axis of symmetry? It's that line that goes right down the middle, and then you have identical parts on both sides. Or, you know, you draw a square and you draw a line down the middle, and then, I've got a mirror. Those are, you know, that's an axis of symmetry. Well, a parabola has one too, because you could fold it in half. It would be a mirror on either side. So that's what we're going to find. And the formula for that, for that line, that axis of symmetry, is x equals negative b over 2a. That's your formula. Remember it, memorize it, lock it away, throw away the key, keep it in there. It's important. Now that b and that a that they are referring to in this formula come from up here. Let's see what the axis of symmetry is for a couple of different parabolas. Move up, move up. Okay. So let's say something like y equals x squared plus 5x plus 6. Okay, I need a b and I need my a. Well, you're like, oh, but there isn't a number in front of the x squared. But there is. You just don't see it. It is an imaginary 1. Anytime you don't see it there, it's an understood or imaginary 1. So the axis of symmetry for this line would be negative b, my b is 5, negative 5 over 2 times a, which is 1. My axis of symmetry is negative 5 halves. So that means if I was graphing that parabola, there's 1, 2, 3, it means there would be a line right there that this parabola is going to be mirrored across. That's my axis of symmetry. Okay. What if it was something like another scenario where you have something like, come on, I just need a pen. There we go. Like y equals 3x squared. What's the axis of symmetry? You're like, wait a minute, there's no b and there's no c. How am I supposed to do x equals negative b over 2a when there's no b? Well, this is the one where it's 0. There are 0 x's, and there's 0 just plain numbers on the end. So negative b in this case is just going to be like, we could say negative 0. I know that seems silly, but negative 0 over 2 times a, that's 3. 0 over 6, 0. Axis of symmetry is 0. This one is going to be centered right on the y-axis, where x equals 0. Okay, so that's finding your axis of symmetry. Now, if you've noticed something up here, if I look at a parabola, I'm telling you, it's not easy to draw a straight line on a on a laptop screen that's moving around and wiggling. Let's use a ruler. Let's be smart. Okay. All right, so let's say I have a parabola and that I find out that back here, say something like x equals negative 4 is my axis of symmetry, and my parabola looks something like that. Do you notice something about this parabola? About how low it goes? And then it starts going back up? Do you see that its lowest point is on the axis of symmetry? If this were like an upside down, a negative one, like a negative x squared, it's the highest point. You may have heard these terms before, maximum and minimum. Here, the lowest point is its minimum. Here, highest point is its maximum. So that is either the maximum or the minimum. That is the vertex. That's our goal. And we know it's on the axis of symmetry. Always, for a parabola. Always, always, always. The vertex, the maximum or minimum, is going to be on the axis of symmetry. So we've got a big help here, because when we find the axis of symmetry and the vertex is on it, we now know what the x value is on that vertex. Hey, if I know the x value, I can plug it into my original equation and I can solve for y. So let's try one. Let's say, black pen, come on. Let's say y equals x squared plus 6x plus 9. Okay, and I don't know what it looks like. I don't have a graph. All I have is this equation. So I go, okay, step 1. I need to find the axis of symmetry. I actually can write quite neatly when I'm not writing on a laptop screen that's moving, I promise. And my formula for the axis of symmetry is x equals negative b over 2a. Well, I'm looking over here. My b, for ax squared plus bx plus c, my b is 6. So negative 6. And my a is that imaginary or understood 1, the invisible, not imaginary, invisible 1 is the better term there, invisible. Okay, so 2 times a is 1. So negative 6 divided by 2, negative 3. X equals negative 3. So if I want to visualize this, I don't know exactly, I don't know why it doesn't want to zoom out. Okay, thanks whiteboard, you're so helpful. Okay, so let's do a little quick sort of visualization. This is by no means to scale. Okay, so I know that x equals negative 3, this is my axis of symmetry, and that this parabola is over here somewhere. I don't know where it is yet, but I know there's a parabola somewhere, and this is a positive x squared, so I know it's opening up. I'm like, I don't know where it's at yet. I don't know if it's down here, up here, I just don't know. But I do know it's on this axis of symmetry and that its vertex is on that axis. Okay, so at that vertex, x equals negative 3. All right. Well, if x equals negative 3 at the vertex, Then I can go back to my original equation and I can plug in -3 and I can solve for y. So this is our step 2. Plug x in, solve for y. Those are our 2 major steps. There, I want to zoom out. Woohoo! Thank you so much. Okay, so -3 squared is 9. 6 times -3 is 18. Okay, 9 plus -18 is -9. -9 plus 9 is 0. Okay, so y equals 0. So now I know my vertex is -3, 0, which means it's right there. And there's my approximate of what it's going to look like. All right, so again, our 2 steps here. 1, find the axis of symmetry using x equals -b over 2a. Then take that x and plug it into your original equation. This lets you solve for y. And then you have your answer. You have your x from step 1 and your y from step 2. If you have any questions about this, please leave them in the comments below, or if you have a topic that you would like to see. Again, if you're looking for vertex form, there will be another video coming out very shortly on that. Link will be in the description below. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.